A single bright dot can change everything we think we know. Imagine looking up at the vast, dark night sky. See it not as a ceiling, but as a deep and endless ocean. For as long as we have been human, we have looked up and wondered what lies beyond our sight. Now we have a new tool that lets us see further than ever before. This tool, the James Webb Space Telescope, has found something unexpected. It has found a dark surprise, a shadow, at the very edge of the universe. This discovery is both small and huge at the same time. To understand this new discovery, we must first understand the tool that made it possible. The James Webb Space Telescope, or Webb, is not just any telescope. It is a magnificent eye in space, a marvel of human engineering. Imagine a giant mirror made of 18 golden hexagons, folded up like origami to fit inside a rocket, then carefully unfolded 1,000,000 miles from Earth. This mirror, more than 21 feet across, is its great light-gathering eye. It captures the faintest, most ancient light in the cosmos. Signals that have been traveling for over 13 billion years to reach us. Unlike the Hubble Space Telescope, which sees mainly in the visible light our eyes can detect, Webb is a specialist. It looks at the universe in infrared light. This is a kind of light that is invisible to us, but it is incredibly important for astronomy. Think of it like having a superpower. Infrared light can pass through the vast clouds of cosmic dust that block our view. Newborn stars, distant galaxies. More importantly, as the universe expands, the light from the very first galaxies gets stretched out. Scientists pointed the James Webb Space Telescope toward a region of the sky they believed would be a treasure trove of early galaxies. Based on our best theories, this area should have been teeming. They expected a sky full of flickering candles. Instead, in one part of the image, they found a profound lack of light. A patch where the density of bright, young galaxies was far lower than predicted. This was not an equipment failure or a blind spot. It was a genuine feature of the early universe. This finding has been called a dark discovery, a name that perfectly captures the sense of mystery. It simply means they found an absence where they expected a presence. Imagine mapping a new continent, and you find a vast desert where models predicted a lush rainforest. This dark patch is that desert, a quiet, empty-looking space that speaks volumes about the conditions of the cosmos in its infancy. When astronomers talk about the edge of the universe, as far as we know, has no physical edge. The edge is in time. The sun's light takes 8 minutes. Alpha Centauri's takes over 4 years. Webb is designed to see galaxies more than 13 billion light-years away, as they were when the universe was only a few 100 million years old. We cannot see older than 13.8 billion years. This ultimate horizon is the observable universe, a sphere with us at the center. Webb peers into the cosmic dawn. The dark discovery was made at this ancient epoch, at the boundary of our vision. Finding a patch of darkness there is like finding a blank page in the first chapter of the cosmic storybook. Imagine a small, dimly lit control room. It is late, well past midnight. Dr. Eris Thorne sits hunched over a large monitor. His coffee has long since gone cold. The screen displays a mosaic. His eyes are fixed on one specific area. He wipes it away with his sleeve. There it is. The number of high redshift galaxies drops off. It is emptier than their models could account for. A slow smile, a quiet thrill. Lower than expected galaxy count in Sector 7G. Redshift Z greater than 10. Check for dust obscuration. Gravitational lensing effects ruled out. He picks up his phone and sends a short, simple message. He sees the early universe, hydrogen gas, slowly cooling, pockets collapsing, lighting up their cosmic neighborhoods one by one. A region that remained quiet a little longer. For a moment, a time traveler, replaced by the warmth of a new and beautiful question. This dark discovery might seem subtle, but it is genuinely exciting. There are three clear reasons why this finding is so important. First, it directly challenges and refines our map of the early universe, more texture and personality, regions developing at different speeds. Second, a perfect example of the scientific method. Theories predicted a sky full of bright early galaxies. Webb saw surprising darkness. It tells us our theories are incomplete. Third, it opens a realm of questions. Why was that region dark? Scarcer raw materials? Unknown forces? Different first stars? Each question a doorway, refining our map, driving the scientific process, sparking new questions. The universe is not a solved problem. It is a living, active mystery. Now that scientists have found this mysterious dark patch, the great work of explaining it begins. Several intriguing ideas are already being discussed. One explanation: the galaxies are hidden. Vast clouds of neutral hydrogen block certain light, cloaking young galaxies. Webb can test this via specific spectral signatures. Another: star formation was delayed. Gas needed to cool and collapse. Maybe this region was hotter or less dense, postponing its first stars. A more exotic idea: an unusually large underdensity, a cosmic desert with less matter to begin with. Fewer galaxies would form. Each can be tested. Spectrographs for chemical fingerprints, survey boundaries, sharp or gradual. Compare many regions to piece the puzzle together. Whatever the answer, it will teach us about the rules that govern the universe's construction in its first moments. This discovery is not just about stars and galaxies. It is profoundly human. Decades, thousands of scientists, engineers, technicians, programmers from all over the world. They faced challenges, budget overruns, technical setbacks, and invented unique mirrors, an ultra-thin sunshield, hypersensitive cameras. The launch had to be perfect, deployment flawless, no repair mission. Each successful step brought joy and relief. Insights happen in a global community. Collaborate, compete, challenge. Data made public. 1,000 new conversations begin. The thrill of discovery, felt by one scientist in a quiet room, belongs to all of us. In the end, it gently shifts our perspective. We live on a small, fragile world, orbiting an average star in a quiet corner of a vast galaxy. Yet we built Webb. We can now read the faint, ancient light from the universe's first morning. The dark discovery offers deeper wonder. Each new discovery, each new puzzle, connects us more deeply to our cosmic heritage. We are not separate from the universe. We are part of it, and our curiosity is one of its most interesting expressions. With Webb and the telescopes to follow, we will find more surprises, more puzzles, more wonders. The dark patch is just the beginning. For now, let us pause and appreciate this moment. We have looked further back in time than any humans before us and have been met with a beautiful new mystery. The sky is not just distant lights. It is a vast book filled with stories. We have glimpsed a page we never knew existed. The universe still has stories to tell, and we, with endless curiosity, are finally ready to listen. The universe is speaking to us in the language of light and shadow, and we are finally learning how to listen to its ancient and subtle voice.